This video will cover independent and dependent events of compound probability. Before we get to that, we're going to talk about a warm-up question, simple probability. You have a bag of marbles with 6 blue marbles, 4 red marbles, and 2 purple marbles. You see it here. What is the probability of getting a blue marble? How many blue marbles are there? 6. How many total marbles are there? 12. So 6 out of 12 chance, which is the same as the fraction 1/2, or 50%. So the probability of getting a blue marble is 1/2. What is the probability of getting a red marble? How many red marbles do we have? 4. How many total marbles do we have? 12. 4 twelfths will simplify to 1/3. So the probability of a red marble is 1/3. What is the probability of getting a purple marble? How many purple marbles are there? 2 out of the 12 total marbles, which is 1 out of 6. So the probability of getting a purple marble is 1 out of 6. That should be simple probability review. As we move on, you have a bag of marbles with 6 blue marbles, 4 red marbles, and 2 purple marbles. What is the probability of getting a blue marble and then getting a red marble? There's a major question we need to ask. Once I take my blue marble, am I going to replace it before I take my red marble? The blue marble probability is 6 out of 12. My red marble probability is 4 out of, I'm not sure. What do I need to do? Well, if I don't replace my blue marble, then it is 4 out of 11. If I do replace my blue marble, then it's 4 out of 12. We will talk about this as we talk about independent and dependent events. Let's say that I'm going to call on students by drawing names from a cup. Here's a cup. Has names in it. After the student answers the question, their name goes back into the cup. So if I pick Max, and then I put Max's name back in, I still have the same number of students that I began with. And whoever I pick next, the fact that I picked Max first, doesn't matter. It's not going to affect whether I pick Noah second. Dependent events. I'm going to call on the student by drawing a stick out of the cup. After I've called on Kendra, then her name doesn't go back into the cup. So now I have fewer people and to choose from when I make my next selection. So the first pick did have an impact on who I pick second. Therefore, they are dependent events. Here are some key things to remember about independent probability and dependent probability. You pick something, then you return it in independent probability. Dependent probability, you pick something and you keep it out. Replacement versus no replacement. Denominator stays the same every time because you have replaced. Denominator decreases after every pick because you do not replace. Item has the same probability of being picked each time because every time I put that student's name back in the cup. Item has a better chance of being picked each time someone else is picked until I only have one selection left. Keywords to remember in independent: replaced, returned, put back. Keywords for dependent: keep it, do not return. Independent, there can be multiple picks as long as one item is picked at a time. Dependent, same thing. There can be multiple picks as long as one item is picked at a time. Let's look at these examples and determine whether it's independent or dependent. A jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. Once a candy is drawn, it is not replaced. Find the probability of getting 2 greens. Did you see a key word here? Not replaced. Independent or dependent? Would be dependent. Because if I remove something, it's going to impact what I do second. A jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. Once a candy is drawn, it is returned to the jar. Find the probability of getting a green, then a blue. Keyword here is returned. If it is returned, I'm going to have the same number every time. That means it is independent. A card is drawn. From a deck of 8 cards with letters A, B, C, D, E, F, G, and H. The card is replaced, and a second card is drawn. What is the probability of getting a B and an F? Keywords is replaced. If it is replaced, that means it's not going to matter. Independent. A card is drawn from a deck of 8 cards with letters A, B, C, D, E, F, G, and H. The card is not replaced, and a second card is drawn. What is the probability of getting a B and F? Keywords. Not replaced. If it is not replaced, then they will be dependent. To solve for independent and dependent, multiply the simple probabilities of each pick. Make sure to take into account if the item is replaced or kept. This would be the rule. The rule for finding independent and dependent is to multiply the simple probability of each pick. Here's dependent in probability. A jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. Once a candy is drawn, it is keyword not replaced. Find the probability of getting 2 greens. Okay, first of all, how many total candies do I have? I have 6 blue plus 3 red plus 5 green plus 2 yellow. 9 plus 7, 16. Okay? The probability that on my first pick I'm going to get a green. How many greens do I have? 3. Out of how many candies total? 16. My rule says I'm going to multiply times. I did not replace. So that means how many candies do I have left? 15. How many green? Assuming that I took 1 the first time, I have 2. So 3/16 is the simple probability for my first green, and 2/15 is the probability of my second green. I'm going to simplify before I multiply to make my multiplication a little easier. So the probability of getting 2 greens is 1 out of 40. Independent probability. Here's why we know it's independent. Same question. 6 blue, 3 red, oh, not totally, yes, 5 green, and 2 yellow candies. Once a candy is drawn, it, keyword, is returned to the jar. Find the probability of getting a green and then a blue. Total numbers still 16. How many of the 16 are green? 5. How many, this time since it is returned, I still have 16 again the second time. How many are blue? 6. I'm going to simplify before I multiply here again. Simplify by 2, that would be 3. And this would be 8. 5 times 3 is 15. 16 times 8, 48, carry my 4, 12. 15 over 128. Independent and dependent probabilities. Remember, your rule is to multiply the simple probabilities of each pick. Let's look at our guided practice here. Here's these letters. A card is drawn from a deck of 8 cards with letters A, B, C, D, E, F, G, and H. The card is replaced and a second card is drawn. What is the probability of getting a B and F? Okay, key word here, yes, is replaced. How many total letters do we have? 8. How many B's? 1. Since it is replaced, how many letters will I have to choose from in my second one? 8. How many F? 1. My rule says that I do what with these probabilities? Multiply. 1/8 times 1/8 is, you guessed it, 1 out of 64. How about the second one? A card is drawn from a deck of cards with the same letters. The card is not replaced, and a second card is drawn. Find the probability of a B and an F. Keywords, not replaced. Probability of getting a B. There's 1 B out of how many cards? 8. I'm not replacing, so next time, how many cards will I have to choose from? 7. How many of the 7 are an F? 1. The rule says that I do what with my simple probabilities? Multiply. 1/8 times 1/7 is 1 in 56 chance. I want you to work on these problems. Solve for the independent or dependent probabilities appropriate. I will move the red check in a few minutes inside the green box to see if you have the correct solution. You are not ready. Please push pause. Let me check your answers. 2 red candies, if replaced. I'm replacing. My denominators will stay the same. 16 both times. 3 reds, 3/16 times 3/16. Number 2, a yellow, then a blue, replacing. Again, both times denominators would stay the same. 2/16 and 6/16. Simplifying that. Number 3, we have 3 items this time. 2 greens, then a red. 5/16, 5/16, and 3/16. Number 4, 2 blue candies, not replacing. My denominator changes this time. 6/16 and 5/15. Number 5, not replacing, so my denominator will change again. Probability of a red, then a green. And 6. 3 greens in a row, we're not replacing. Each time my denominator will change and get 1 less and 1 less. Closing. Your own words describe the difference between simple probability and independent and dependent probabilities. Solving problems that have dependent versus those with independent. Something to think about. In addition, some reminders. P and then an event is the probability that something will happen. Looking on your note sheet, you have some sample questions to answer yourself. Please have those answered and ready for class discussion on Friday morning or afternoon. Have a good day. Goodbye, eighth graders.